Example for piecewise defined functions. Let's graph this f of x, and so f of x be x when x is less than -2, 0.5x between -2 and 0, -2x between 0 and 4, 3x minus 16 when x is bigger than 4. And notice each piece, the purple piece is a linear function y equal to x, and then the blue piece is y equal to 0.5x is a linear function, and the orange piece y equal to -2x is a linear function, and y equal to 3x minus 16 is a linear function. So each piece can look like an elementary function that we know, but they're in their domain they are elementary function. There are functions that we know, and then we piece them together. And when I'm saying in their domain, each piece has its own domain. Basically, it's a domain that was basically restricted that piece of the function. And so the entire routine goes like this. You divide. Remember, there were cutoff points. The -2 was one cutoff. To the left of -2 was x, to the right of -2 was 0.5x, 0 was another cutoff, to the left of it was the function 0.5x, to the right of it was -2x, 4 was another cutoff, to the left of it was -2x, to the right of it was 3x minus 16. So what I do is I break down the entire number line by how many cutoffs? 1, 2, and 3 by 3 vertical lines. One is x equal to -2, one is x equal to 0, one is x equal to 4. Then that divides the entire plane into 4 pieces. The piece 1 is going to be the purple function, the piece 2 is going to be the blue function, and the piece 3 is going to be orange, piece 4 is going to be the teal function. And so to graph those, because I know how to graph lines, I just use 2 points, and I choose those 2 points to be within the domain. And so I choose the x value to plug in to be within the domain to find those linear functions, and we put them all together. So now an absolute value function is also a piecewise defined function. So how do we define it? Define absolute value of x. We say it's x when x is bigger than or equal to 0. It's -x when x is less than 0. Whatever is inside bigger than 0 is it inside. Whatever is inside less than 0, it's negative of the inside. Sometimes people doubt this. Just put in a few points. Let's say what is absolute value of -1? That is -1. That's correct. That's the second rule. What's the absolute value of 2? That's 2. That's the first rule. So let's just check a couple of points and to make sure that it's working. So according to what we said, now we have f of x equal to absolute value of x minus 2. When x minus 2 is positive, this is going to be x minus 2. When x minus 2 is negative, it's going to be negative parentheses x minus 2. And 0 can go with either of them, basically. And now, to resolve this part should be just a restriction on x, it doesn't look like the normal restrictions we put in. And how do we make it into the normal restriction we put in? We just solve x minus 2 bigger than equal to 0. We solve that for x, and it's x bigger than equal to 2. This could be a quadratic function, it could be a cubic function, it could be sine and cosine function. As long as you remember, you have to set the inside bigger than 0, set the inside less than 0, and then solve for x. It's going to work perfectly. And so this is the graph of the absolute value of x minus 2. It looks like the line x minus 2, where you basically find a mirror image of whatever is under the x-axis rather than just having that graph. So you basically break it into everything below x-axis to be the mirror image.